helps. Okay, so if I have the equation 3x minus 4 equals 6, or sorry, plus 4 equals 16, first of all, the goal in any equation is to get the variable on one side and the equal sign and everything else on the other side. Basic math, inverse operations, stuff that we should be able to do, especially these easy ones, with our eyes closed, right? So if I wanted to get that 3x by itself, what would you say I do first? Subtract the 4. We got to get it over with the 16. And so then we end up with a 3x. Our 4's cancel. And 16 minus 4 is 12. And so then to get that x completely by itself, how do we get rid of the 3? Divide. And our answer is x equals 4. And how would we check? If we wanted to, how could I check? Plug the 4 in for the x. As long as it makes a true statement in that original equation, then we are good to go. And we know we have the correct answer. Am I going to make you check it? No. But if you want to make sure you have it correct, yes, you can. Number 2 is even easier than number 1. 5x equals 35. What do I do? Just divide by 5, yeah. And x is going to equal, I was about to say 37 for some reason. I don't know. 7. Okay. If I get going too fast, let me know. I know this is easy and it's not going to take a lot of time, but just when we get going and stuff, if I start going too fast, just tell me to slow down a little bit, okay? Everybody good? All right. Go ahead and work on those. They progressively get a little bit more difficult, but still nothing that is unsolvable at this level. We've all been through algebra 1 and algebra 2. Some of us even more than that. Let's throw in that little nasty fraction there. All right, number 3 is negative 3 plus n equals 12. This one is not hard. However, there is a mistake that is made on this one a lot. What kind of 3 is that in the front? It's a negative. And I need to get it away from that n. It is being added to the n, but it is a negative 3, which means how are we going to move that to the other side? Christian, is that right? All right, with your name? Okay, say it again. Add it. Yep, I need to add that 3 over. It is a negative 3, so in order to move it to the other side, even though it is being added, did not mean to do that. Although it's being added to n, it is a negative 3, so we're going to have to add it to get it over to the other side. And that would give me 15 for our answer. Why does 4 scare people? Because it has a fraction, okay? Tomorrow, we are dealing with nothing but fractions in our equation, so we're going to start with this basic one here. When I have a fraction multiplied by a variable and I want to get rid of that fraction, we can do a couple of different ways. And depending on what the fraction is, this one's a relatively simple fraction, but if it were a bigger fraction, you can do it all in one step, or you can break it down into multiple steps. And I have found that breaking it down into multiple steps is easier for most everyone to understand. Okay. So what we can do is we can get rid of those fractions by multiplying the entire equation by the denominator. Okay. In this case, we only have one fraction, so we only have the one denominator to worry about. When we get to multiple fractions tomorrow, we'll talk about how to do it then. But what is the denominator of my fraction? 5. So what I can do is, to make my equation easier to solve, is I can multiply both sides of this equation by that denominator 5 and make that fraction disappear. Okay, so that's what I'm going to do, is I'm going to multiply both sides by 5. Whatever I do to one side of an equation, I have to do to the other. And what happens is when I multiply 5 times 1/5, okay, these 5's cancel each other out, right? One's at the top, one's at the bottom. And so that leaves me with that numerator that then gets multiplied by the x. Well, what is 1 times x? It's just 1x. So this left side here becomes just 1x. And then I multiply the 3 times the 5, which gives me 15. My fraction is now gone. The equation is actually now solved. But if there was a number in front of that x, I could divide by it after that. Some people get rid of fractions by multiplying by the reciprocal. That works as well, but it gets complicated when you have multiple fractions in your equations. So that's why I say if we deal with it one at a time, just get rid of the denominator and go from there. Is everybody all right with that one? What's a little bit different about 5 versus the first 4 that we did? What? Go ahead, Christian. Variable on both sides of my equation. Now, with these types of problems, there are multiple approaches as to how you get to the right answer. It does not matter to me. Some people prefer to take the smaller variable and move it over to the bigger variable. Some people prefer to move all of their variables to the left side. It really just depends on what you're comfortable with as where you want to start. What I would recommend is making sure that I don't have any like terms on each side of my equation before I start. So if I look at the left side of my equation, I've got a 3x and a 5. Are those like terms? No. And then I have on the right side, I have a 25 and a 6x. Are those like terms? So again, it's a bunch of different ways we can do this one. I like to move my variables first. Some people don't do that. As long as you can get me to the right answer, I don't care how you start this thing, okay? But I'm going to ask you, would you rather me move the 3x to the 6x or the 6x over to the 3x? 6 over to the 3? Okay. So I'm going to take and I'm going to subtract my 6x over to my 3x. You could also, whoops. Where's my undo? Oh, come on. I'm not used to using PowerPoints. You'll have to bear with me until I get used to these. So I'm going to subtract my 6 over here. So that's going to give me a negative 3x. Bring down that minus 5 and bring down that 25. Those 6x's are gone. If I wanted to, I could have also taken that 3x and subtracted it over to the 6x. It does not matter. Now I have negative 3x minus 5 equals 25, so I need to get that 3x by itself. So I'm going to add the 5 over. And I get a negative 3x equals a positive 30. So I divide by negative 3. And what did you guys get for x here? Negative 10. Just be careful with your signs. Anytime, like for example, if I would have taken that 3x and subtracted it with that 6, a lot of the times people forget the negative in front of the 5 when they bring it down. So just be mindful of your signs. Be careful as you go through these. This one little sign error can throw off the whole problem. 6 is a little step up. Why? What do we have in 6 that we didn't have before? Parentheses. And anytime you have parentheses in an equation, you have to get rid of those by distributing. Yes. So the first thing we want to do is we want to take, and we want, excuse me, to distribute that 4 to both the x and to that 3. One mistake that's made in problems like this is people forget to distribute that number to the second term in parentheses. Remember, whatever's outside the parentheses has to be multiplied by everything in the parentheses behind it. Now it turns into an equation just like number 5. I've got variables on both sides. It doesn't matter which way I go. I personally tend to usually move my variables to the left side just because we're used to seeing x equals. It doesn't mean you have to. Some people move the smaller to the bigger. That's perfectly fine as well. I'm going to take and subtract my 2x over here, over to the 4x. And again, if you did this differently, as long as you get the same answer, I am fine with that. Excuse me. Now what would I do? Add the 12. So I get 2x equals 24. I divide by 2, and x equals 12. Are we okay with this? Still not too terribly difficult, right? All right, last two, a little bit harder. I want you to try these. With number 7, I'm going to distribute my 2. That gives me 2x minus 2. Do I distribute the 2 to the 3 that's back behind the parentheses? No. Okay, I just bring down that plus 3. And again, just like we talked before, that is x minus 3 times x plus 1. So I'm going to bring the x down. I'm going to distribute, but when we do that...
For an interruption, at this time, we'd like to ask any 10th graders with the last name A through E to come to guidance if you are missing a graduation requirement in your schedule, if you have a blank period, or if you have a duplicate course. That's only 10th graders with the last name A through E. Thank you.
When I distribute, I need to distribute it as a -3, so make sure you're careful with that. One little sign mistake will cost the whole problem to become wrong, okay? So just be very careful. I like to combine my like terms on both sides of my equation before I move stuff. If I'm looking at the left side, I have a 2x minus 2 plus 3. So I have two terms that are constants that I can combine. So that's going to be 2x, a negative 2, and a positive 3 gives me a positive 1. I'm also going to combine my like terms on the right side. I have 1x and a negative 3x that can be combined together to give me a negative 2x. And then I bring down that minus 3. And again, at this point, it doesn't matter which way we move as long as we get all of our variables on one side, everything else on the other. So I'm going to take and add my 2x, my negative 2x over to the other side, to the left side. That's going to give me 4x plus 1. That equals a negative 3. That's what's left here, so make sure you bring that down. And I'm going to have to come over to the side here because I'm running out of room. And now we have a little bit a little bit easier equation. I don't know what I was thinking, to continue to solve. So we're going to subtract our 1 to get our variable completely alone. And then when we divide, what did we all get for that? X equals negative 1. Okay, just be careful with your signs. Again, if you did not approach the solving as the same way as I did, as long as you got negative 1, you're good. Okay, I'm not going to tell you have to do it exactly like I do. Some people's brain thinks differently, and as long as you can get to the right place, I'm good however you get there, as long as it makes mathematical sense. All right, last one. Do I distribute that 2a to the a plus 6 in parentheses? No, it's going to come down. The only thing I do distribute is that negative 9. It is a negative 9, so when you distribute, make sure you distribute it as a negative. Again, I like to combine my terms. Here on the left, I have a 2a and a negative 9a. That's going to give me negative 7a. I have a 6a and a negative 4a, which is going to give me 2a. And I'm going to go from there. I'm going to subtract my 2a. That gives me negative 9a. Bring down that minus 54. Those are gone. That's going to give me a positive 18. I'm going to come over to the side again. Don't have much room. To get my a by itself, I'm going to add my 54 over. That's a negative 9a. Those are gone. 72. And then I divide. And what do we get for a? Negative 8. Again, as long as you get to the final solution of negative 8, you are good no matter how you got there. A couple of things. People need to stay off their phone because I'm not quite done with the notes yet. We should not have our phones in our laps, in our hands, nowhere to be seen so that I do not have to take them away. Most of you did very good at that. Thank you. Anybody have any questions?